Welcome to clickmyproject.com. Let us discuss about the product on multimodal sensor medical image fusion based on Type-2 physiologic in NSCT domain. Let us discuss about the abstract. Multimodal medical image fusion method that adopts a multi-skill geometric analysis of the non-subsampled controller transform with physiologic technique. First, the NSCT was performed on pre-registered source image to obtain their high and low frequency subbands. The NSCT inherits the advantages of the CT while also possessing shift invariance and effectively suppressing pseudo-Gibbs phenomena. Thus, the NSCT is more suitable for image fusion. The key problem in the transform domain based fusion algorithm is the selection of fusion rules. For low frequency coefficient, the simplest way is to carry a weighted average of the coefficients. However, this rule decreases the contrast in the fused image and cannot result in high quality fused subimages for medical image processing. Because of their modeling uncertainty, physiologic-based image fusion method usually yield better performance than classic image fusion method. Physiologic is applied as either a future transform operator or a decision operator for image fusion. An effective physiologic-based fusion rule is proposed for fusion of the high-frequency subbands. The local fuse entropy is introduced to automatically select the frequency coefficients. However, for the low-frequency subbands, they were fused by local energy algorithm based on the corresponding image's local features. Finally, the fused image was constructed by the inverse NSCT transform with all composite subbands. Let us discuss about the flow diagram of the product. For medical image fusion, we have taken two medical images as input, such as CT and MRI images. Computer tomography of the head or computer axial tomography scanning uses a series of X-rays of the head taken from many different directions, typically used for quick viewing brain injuries. CT scanning uses a computer program that performs integral calculation. Typically, the information presented as a series of cross sections of the brain. Magnetic resonance imaging of the nervous system uses magnetic fields and radio waves to produce high quality 2D and 3D images of the nervous system structures without use of ionizing radiation or radioactive. MRI is based upon the science of nuclear magnetic resonance. Certain atomic nuclei can absorb and emit radio frequency energy when placed in an external magnetic field. And then pre-processing. Both images has been taken for pre-processing. Pre-processing is nothing but grayscaling and resizing of image. Input image is converted into grayscale image and then resized. A grayscale image is simply one which the only colors or shades of gray. In computer graphics and digital imaging, scaling refers to resizing of digital image. When scaling a vector graphic, the graphic primitives which make the image can be scaled using geometric transformation without any loss of image quality. When scaling raster graphics image, a new image with higher or lower number of pixels must be generated in case of decreasing pixel numbers. This usually results in visible quality loss. After pre-processing, we perform NSCT transformation. NSCT is nothing but non-subsampled controller transform. The non-subsampled controller transform was developed mainly because the controller's transform is not shift invariant. The reason for this lies in the upsampling and downsampling present in both Laplacian pyramid and directional filter banks. The method used in this variation was inspired by a non-subsample wavelet transform or stationary wavelet transform which were computed with trust algorithm. After transformation, we get both low subband and high subband images. Low subband and high subband images as output. Low subband, we have fused the coefficients of the low subband with local energy and high subband coefficient with physiologic. Physiologic is a form of many value logic in which the truth values of variables may any real number between 0 and 1. Considered to be fuzzy. By contrast, in Boolean logic, the truth values of the variable may only be crisp values of 0 or 1. Fuzzy logic has been employed to handle the concept of partial truth, where the truth value may be ranged between completely true and completely false. The fuzzy logic processes fuzzy all input values into a fuzzy membership function, execute all applicable rules in the rule base to compute the fuzzy output function, defuzify the fuzzy output functions to get crisp output values, and then we perform the fused low subband, fused high subband inverse transformation. Inverse NSCT is the NSCT reconstruction process, and then we get the output image as fused. The output of the inverse transform is the fused image. Let us discuss about the running procedure of the product. For executing the product, run the main file. Select the input images from the dataset. Input images processed, and we get so many outputs. These outputs are all related to our flow diagram. Figure 1 is input image and figure 2 is non-subsample coefficient level 1 for image 1. Figure 3 is level 2 for image 1. Figure 4 is level 1 for image 2. Figure 5 is level 2 for image 2. Figure 6 is low subband fused image of both images. And figure 7 is high subband fused image for both images. Figure 8 is fused in both fused images. This is the final output of our product. Thank you for listening.